23.32 and the other one is figure what?
23.2 or 23.32. That's for the older books.
23.2 and 23.32. But for the new one, it's... Anyway, there's the flow chart there. That gives you the story of your digestive system. I want you to look at this liver. Okay? We're going to appreciate our liver. So this is how the liver looks like when you make slices of it, a tissue slide of it. This is how it looks like. Okay? Again, this is your liver, like this. When you cut it up, it looks like this. I want to use this one just so we understand how it works. So I'm going to use, so this is how it looks like. See, it is made up of rows and rows of cells. The cells of the liver are called hepatocytes. Hepatocytes. And you see the green one? So there's blood that goes up. Remember the inferior vena cava? So it passes through the liver. So there's we're going to talk about this portal circulation in a minute. But I want you to look at this liver first. So these are the cells that make up your liver. It's called hepatocytes. And they say, you know, it's similar to when you open a book, right? You try to open that book and have the ends of the book touch each other, so it will be like an accordion. Can you picture that in your head? And so that's the same thing with the liver. So these are the individual hepatocytes, okay? And some of these hepatocytes, they make the bile. What's the composition of bile? It contains cholesterol plus the bile pigments, right? From your red blood cell breakdown. There's bile pigments in there. And so that's how, and the direction of flow of bile from these hepatocytes, they go down here. They are collected in this bile duct and they drip into your gallbladder. Okay? There are many other functions of the liver, not just another, but there's many other functions of the liver. Now I want you to look at this slide over here. This one over here, okay? So, look at, do you remember artery? We're going to include in this slide. Your heart, right? There's the heart, the aorta, right? Going down. So remember this aorta is going to your systemic, then it breaks down into capillaries right here. Break down into capillaries right here. So these are the capillaries. So I'm going to connect with these capillaries. This one right here. Right? So artery, capillary. So this is the aorta. Then this is your mesenteric artery. Then going to the small intestine. And what's in here? Your nutrients. Right? Your nutrients are here. Your amino acids. Right? Your glucose. Your free fatty acids, they are here. And so they're going to be picked up by these capillaries, right? And then you have mesenteric vein, so they empty into veins, mesenteric vein. And then look, it goes to the liver, okay? But it breaks down. So this is what you call portal vein. And it breaks down into another set of capillaries. This is very important for you to understand. I want to go back here to the small intestine. I know that you are, I don't know about you, but I know that every time there's always new findings. They say cooking with Teflon is now dangerous to your health. Have you heard that? There's always something, or now you want BPA free or whatever, right? Because they say it's proven to give you cancer, etc., etc. And you never know. Maybe even what do they say? The food preservatives, there's arsenic in there, etc., etc. They're also here, right? I will consider them as toxins. So they're there, possible to give me harm. Do you follow? Maybe there's bacteria in here too that I ingested. So they will be included in here. They will be part of the nutrients that's entering me. You see that? Okay? And this is where your liver is so important. Oh, in addition, the drugs that I took, right? The medications that I took, alcohol maybe that I ingested, right? If I took some wine, lots of alcohol, they're there too. They're going to be part of, everything will be absorbed by my blood. But not everything is good for me, right? There's a lot of them that can possibly harm me. When it enters, look at, it's gonna end in the blood, in the heart will pump it. So we have to solve that. This is where the liver is so important. Look at what the liver will do. Functions of the liver. Where is that? Look at what the liver will do. It serves to detoxify. So I'm going to look at, I want you to picture in your head. So I'm going to go back to this picture over here. Now can you picture in your head, what is that? This is called the portal vein. Can you picture in your head what's in this portal vein? Right? There's nutrients in here, yes. But there may be toxic substances, harmful chemicals that's in here too. You follow? Everybody? Yes? No. Tomorrow sometime. Okay? But look at, so this is what's referred to as portal circulation, where the vein, instead of going directly, it breaks into another set of capillaries right here in the liver. Remember, only capillaries have openings. So once that portal vein enters the liver, it breaks into another set of capillaries. That's what you call portal circulation. Again, look at, there's capillaries, then vein. You would think vein straight to the heart. But no, it's capillaries, vein, then another set of capillaries here. And that is very important. Look at what your liver cells have. In addition to the typical hepatocytes, look at what lines these capillaries. This is liver sinusoids. Sinusoids are nothing but capillaries. Look at what you see there. You see there what you call Kupffer cells. These are macrophages. In case you have some bacteria maybe that entered, the macrophages can neutralize that. Okay? In addition, the liver is the key for detoxifying substances, mainly alcohol. This is the reason why there is an alcohol limit, isn't it? 0.08, right? It's not the favorite number of the president. They posted that limit, the blood alcohol level, taking into consideration the physiology of a typical liver. By the way, normal adults. If you're a child, young kids, right? That's why they suffer from alcohol intoxication. Their limit is different from ours. And also, what if you're taking drugs or other, medications? Then you have to adjust that alcohol limit, you see? Do you understand? Now, that's just one of the functions. What else does the liver do for us? Look at, can you picture in your head? Just think of this. When it comes to the liver, I always say, just think of it as your little elves. Because isn't it getting the first supply of rich nutrients? It's the first stop. I just absorbed my amino acids right here, right? I just absorbed amino acids, glucose, my free fatty acids. The first stop is this one. And so, as the blood is passing through here, your hepatocytes are very busy. as the nutrient-rich blood is passing through here, the hepatocytes, the individual hepatocytes are very busy. They're grabbing the glucose to pack themselves with liver glycogen. You remember? Isn't it that the glycogen is stored in liver and muscle? Right? And as the nutrients are passing here, my hepatocytes are grabbing the amino acids to make the proteins that you need. You remember albumin, globulin, fibrinogen, and all the proteins that you find in the blood, it's made by my liver. You see that? Do you understand? Do you follow? And this is why if we have liver failure, how can you control your sugar? Right? If you have liver failure, how can you make the proteins? So a lot of people with liver failure, you notice them with protruding bellies because their liver failed. That's the one that makes the proteins. So if that's the one that makes the proteins, does it make sense that people with liver failure, you control the protein in their diet? Don't you? Because you can go into protein overload. We're going to talk about that when we study nutrition and metabolism. And going into protein overload is dangerous for your kidneys. Do you see what your liver does? On top of the regular activity of the kidney, if you're taking any drugs, let's say antibiotics, it has to detoxify that one. And then you add alcohol. You see? So that's why they post that blood alcohol level. Taking into consideration the normal activity of a normal, healthy liver. It's different for people who are sick. It's different for people who are young. So you can die from alcohol intoxication. And that's why we get drunk, you see? When you go over, you always think, oh, my liver is overloaded, so it spills. You're not able to process the alcohol, it spills, and you feel what you call the buzz. You get drunk. Okay? Do you understand? Are you feeling the buzz of the alcohol? Okay? Do you understand the functions of the liver? So, if we go to this slide over here, where's the liver functions? Functions of the liver. You understand this now. It makes bile, which is important for emulsification. It stores. You see? It grabs. It's the one that is the first stop for all the nutrients that we just absorbed. It will pack itself like the tiny elves of Santa. It will start getting the nutrients, and as it flows through, so whatever is excess, it passes through. That's what the rest of the body uses. But the liver has to pack it, because the liver is the one that will tide us over until our next meal, isn't it? Right? So I had breakfast, then my next meal will be what? Maybe later on, 3 o'clock. So between now and 3, what will tide me over? The liver. Does it make sense? Do you understand, everybody? Okay? What else did the liver do? Maybe I took some, the fat-soluble vitamins A, D, E, and all of those will be processed by my liver. It will also make the proteins that I just, from the amino acids that I just ingested. So and it is also very important for the processing of fats, which we will study when we take up the next chapter. Once we understand how fat is processed, you will understand the term fatty liver, which is the first sign of liver failure. But that's not until chapter 24. Do you understand this slide? And then detoxification. So do you remember the amino acids? Too much ammonia. Remember the ammonia? If we break down amino acids for metabolism, I said there's a buildup of this ammonia. Where is this going to go? There you go, to the liver. The liver will convert this to urea, you see? And then send it to the kidney, so you pee out. And it's an automatic thing. It's beyond our control. That's why a lot of people doing the protein diet, protein shake, what is their main problem? They get dehydrated. That's why you advise them to drink lots of water, because it's an automatic thing. When you take in all of these toxic substances in excess, it's automatic. Your body is designed to get rid of it. You get rid of it through your pee. And so you automatically get dehydrated. You have to drink to replace the water that was necessary in getting rid of those toxic substances. Does it make sense, everybody? You understand this hepatic portal circulation? This picture right here? You know, I can't stress enough the importance of your liver. I hope that today, before you go home, you're going to go to maybe Hallmark and buy a nice stationery and start writing. Start having your Dear Liver Diary. Today, I appreciate you. You really have to appreciate your liver. It is just a very, very important organ in the body. You cannot, it's one of those things that we just take for granted. And the problem with all these illnesses or problems that we talk about, it's not until it's grave that we realize, oh, I should have taken care. So that's why when you talk to your friends, or even my Baba, he thinks I'm full of, he said, oh, I don't believe you. It's because, of course, it's not going to happen overnight. But over time, when you're old, that's when the problems will show up. You understand? Okay? There's one more thing I was going to say, but I forgot. Never mind. I will remember. So now we get to the last part. There's one more very important thing about the liver. So as it empties into this central vein and join the inferior vena cava, it has been filtered of toxic substances. What's here is just glucose, just all the nutrients. This is the main filter that tries to protect you from harmful chemicals. Okay? And it also packs itself with glycogen. I'm trying to remember. I think I remember. Slowly, I'm trying to remember. Protein? No, not protein. Fat? Anyway, I'll remember. Okay. So now when we get to the ileum, look at how the ileum looks like. So we're done absorbing in our jejunum, okay? And when we get to the ileum, by the time the chyme gets to the ileum, you have absorbed what you needed to absorb. And so what's here in the ileum is the beginning of feces. And feces is dirty. We know that, right? So that explains why we have these Peyer's patches in the ileum. Okay? Which is lymphatic tissue. Lymphatic tissue. White blood cells, right? They serve to protect us from possible contamination, bacteria. And from here, it will proceed to the colon. By the way, here is how you absorb your nutrients. There's two routes for absorption of your nutrients. Your blood vessel and your lacteals. The lacteal is referring to your lymphatic capillary. That's what you call lymphatic capillaries in the small intestines. It's called lacteals. So in the lymphatic, in the lacteals is where we absorb our fats. We're going to study fat metabolism, all of this metabolism of these nutrients. And in the capillaries of my villus, the small intestine, is where I absorb all the other nutrients. Your glucose, your amino acids, they get absorbed here. Okay, so you absorbed it, and now you're left with feces. And I want you to look at this. This is the beginning of, so this is your ileum. You see they cut it. There's the terminal portion of your small intestine, the ileum. And then you will see the colon. So you have your ascending colon, the transverse, the descending colon, then the rectoid, sigmoid, then rectum, rectoid, rectum, and then you have your anus. Okay? Okay. Look. Right here, look for this in your cat. Look for the appendix. Look at where God put your appendix. Perfect for its location. It's right at the junction between the ileum and the cecum. Okay? The ileum already contains feces, and we know this is all poop. So this is dirty. So the appendix, write down is in your notes. The appendix is not a digestive organ, actually. The appendix is actually lymphatic. It's a lymphatic organ. So it contains lots of white blood cells. And isn't that good in protecting us from bacteria, right? There's lots of bacteria here. So if you have appendicitis, they just take this out. Or if this ruptures, it can be life-threatening. Because they're trying to contain any kind of infection, means there's bacteria in there, and if it ruptures, you remember the mesentery, it can very easily spread the infection. You go into sepsis. I know you've heard of sepsis, right? Overwhelming infection. Okay? So when you get to the colon, is there, first of all, how do I know it's colon? The colon, if you look at it, it has these permanent folds. The reason why it has permanent folds like this is because the smooth muscle of the large intestines is not encompassing the whole wall of your large intestine. They are in columns. So when they contract, they lend to that puckering appearance of your large intestines. And this is why the poop, the feces, has that shape. It is because of these pouches in your colon. Okay? Another feature that is present in your colon and not in your small intestine are these fatty tissues. They're called epiploic appendages or fatty appendages. That's just how you're able to know, to tell the large intestine from the small intestine, just by looking at it. Okay? Is there any more absorption going on in the large intestine? Yes, water. And is there anything? We know that the large intestine contains bacteria, right? Your friendly bacteria. Do they do anything for us? Yes. You give them your leftover food and they give you gas. You fart. There's also other presents from the bacteria. They give you vitamin B12, you remember? Which is important for red blood cell maturation. Do you remember they also give you vitamin K? Right? You had that in one of your worksheets. Remember penicillin? You have to give patients now extra vitamin K because you can kill your friendly bacteria. They're the ones that make this vitamin. You absorb it there. Is there any kind of chemical digestion going on in the large intestine? No more. But there's still peristalsis there, right? Between the small and the large intestine, peristalsis is faster in the small intestine than the large intestine. here the movements, the peristalsis movements here are called mass movements. So they're slow, but they're very forceful. They still keep moving until we get to this part. So when we get to that part, to the anus, you see that there's a sphincter there, okay? And the sphincter in your anus there's two parts to the sphincter, an internal sphincter and an external sphincter. The internal anal sphincter is smooth muscle. The external is skeletal muscle. So by the time the feces gets here, remember you stretch the muscle, you initiate a reflex. So this is what's referred to as your defecation reflex. It's a local reflex that involves your spinal cord, the sacral segment of your spinal cord. So what happens is when the feces lands here, it stretches the wall of your anus right here, and it triggers the defecation reflex. The defecation reflex will relax the internal sphincter, but not the external, because the external is under voluntary control. That is when you feel the urge to go to the bathroom. So how do you poop? How do you poop? Don't you go like this?
Don't you go like
that? Don't you go like that, right? It's pressure driven. Everything is pressure driven. They don't have legs to walk out from here to here, right? We have to move them. We have to do our job, right? So you have to increase abdominal pressure to push them out. And that's the end. So now that we have studied the digestive system, I want to ask you, do you believe in the detox diet?
No.
Do you believe in that one? I don't think so.
Just eat a healthy
It says it will help you get rid of the toxins from your body. What did you get rid of? You cannot. Everything once those toxins enter your body, it's going to get to your liver, right? Right here. Once the toxins enter the body, it's gone. There's no reverse. So that's why I don't believe in the detox diet. Okay? Do you have any questions on the digestive system? So this slide over here, I included some slides. Look at here. This is for your carbohydrate digestion. And it's telling you the site of action, the source. Okay? So you have these terms right here. And the brush border enzymes are the enzymes of my duodenum, the small intestine. They're called brush border because it looks like a brush. When you look at it, and when you open the cat, they look like they're brushy. So that's why they termed it brush border enzyme. Okay? So then the next slide shows you protein digestion and the enzymes. Remember the difference between stomach zymogen and the small intestine zymogen. Here they need acid, here they don't need acid. They're not the same. They're not the same. Okay? Then the next slide shows you fat digestion. And then this one combines everything. So I want you to look at this slide. Okay? Look at this one. Very important. When we talk about our minerals, we don't have to digest them anymore. Okay? But look at how you absorb your minerals and your vitamins. You need to see this. It says follows concentration gradient. Even your water follows a concentration gradient. And this is why when we have diarrhea, right, we need to replace or replenish our electrolytes. That's the only way that we can absorb them. They follow concentration gradient. If not, you're going to be compromised. That's why it's always very important to be adequately hydrated. The next chapter talks about nutrition and metabolism, chapter 24. But that ends our discussion of the digestive system. So I want you now, you take a break for 5 minutes, and then I want you to open up